Good evening to everyone. So, as the topic for today's presentation is to determine the coefficient of notch, presented by Gurneet, Anchit, Anurag, Amit, and Anirudh, submitted to Mr. Shashikant Yadav. So, before starting the presentation, let us see a brief introduction about the topic. As different models are available to find the discharge in an open channel, such as the notch, venturi flumes, WEIR, etc., for calibration of either rectangular notch, V notch, etc., some flow is allowed in the flume. Once the flow becomes steady, the uniform discharge can be easily determined for any of the model. So the first question that arises in our mind is, what is notch? So basically, notch is an opening in the side of a measuring tank or a reservoir extending above the free surface. These notches are used to measure the discharge of an open channel flow by passing, placing, or constructing them across the stream. Or in other words, we can say that the notches are overflow structures where the length of the crest along the flow of water is accurately shaped to calculate the discharge. So now my friend Anchit will continue the next part of the presentation.
Thank you, Gurneet, for passing over the presentation to me. Now we will learn about notches. Notches are those overflow structure whose length of crest in the direction of flow is accurately shaped. Notches can be of different shapes, such as triangular, rectangular, trapezoidal, step notch, etc. The bottom of the notch over which the water flows is known as crest or sill, and the thin sheet of water flowing through the notch is known as nape or vein. The edges of the notch are beveled on the downstream side so as to have a sharp-edged sides and crest resulting in minimum contact with the flowing fluid. The discharge over notch is measured by measuring the head acting over the notch. As water approaches the notch, its surface becomes curved. Therefore, the head over the notch is to be measured at the upstream of the notch, where the effect of curvature is minimum. Now, we will be learning about the assumptions to develop head over the wire. The V notch is one of the most precise discharge, and head over the wire can be developed by making the following assumptions as to the flow behavior. Upstream of the wire, the flow is uniform and the pressure varies with the depth according to the hydrostatic equations. P is equals to rho GH. The face surface remains horizontal as far as the plane of the wire, and all particles passing over the wire move horizontally. The pressure throughout the sheet of liquid or nape, which passes over the crest of the wire, is atmospheric. The effect of viscosity and surface tension are negligible. The velocity in the approach channel is negligible. Now, I'll be handing over the presentation to Amit. Thank you.
Thank you, Anchit. Now, myself, Amit Kumar. After knowing some details about the notches that my friend just discussed, we can determine discharge, which is Q, using the formula 8 by 15 into CD into root 2G into tan theta by 2 into H raised to power 5 by 2. Here, theta is the angle of notch and H is the height of the liquid above the apex of the notch. So as we have calculated Q theoretical, we can calculate coefficient of discharge CD using the formula Q actual by Q theoretical. Now I will talk about the experiment setup. The experiment setup consists of a tank whose inlet section is provided with two baffles for streamline flow, while at the downstream portion of the tank one can fit rectangular notch, trapezoidal notch, V notch. A tank hook gauge is used to measure the head of the water over the model. A collecting is used to find the actual discharge through the notch. Now I will hand over the presentation to Anurag so that he can tell us about the procedure for performing this experiment.
Thank you, Amit. So now I will be telling the experimental procedure to perform this experiment. Firstly, the notch under test is positioned at the end of the tank in a vertical plane and with the sharp edge on the upstream side. Then the tank is filled with water up to crest level, and subsequently note down the crest level of the notch with the help of point gauge. Then the flow regulating valve is adjusted to give the maximum possible discharge without flooding the notch. Then the conditions are allowed to steady before the state of discharge and head H was recorded. The flow rate is reduced in stages and the readings of discharge at H were taken. The procedure is repeated 3 times and the average is found out from all the values of CD. So after the procedure, I am going to tell you the readings of our experiment. Firstly, the head, which is 4.89 centimeter, we get the Q actual 784.7 centimeter cube per second and Q theoretical is 1249.2 centimeter cube per second, for which the CD is 0.62. And for the head of 10.97 centimeter, we get the Q actual of 486.1 and the Q theoretical 741.9, for which the CD is 0.65. And for the third trial, the reading is same as the second trial. Now, the graphs of this experiment will be explained by Anirudh. Thank you.
Thank you, Anurag. Now I am going to explain about the graph of this experiment. The graph is between actual flow rate versus head. This is a straight line graph with slope 2.45, value of K is 15 and coefficient of discharge is 0.63. Precautions: make the water level surface still before taking the experiment. Reading noted should be free from parallax error. The time of discharge is noted carefully. Only the internal dimensions of collecting tank should be taken for consideration and calculation.